Okay, so we're on our first lesson of chemistry. What I'd like you to do is start a brand new page in your book, and could you put down atomic structure and the periodic table? Could you put this down as your main title for the whole topic? Now, obviously, I don't know how long as we go through things you'll need to make notes. So what you could do with is, you can choose when to pause the video and when not to. You can choose when to stop on a certain screen because you need to write something down. I will suggest at certain points maybe you pause and make a note of things. What I'd like you to start with is, just want to do a few quick questions, because when we do Key Stage 3 you will have met this word lots of times, so in Year 7 and Year 8, and hopefully we all have a clear understanding that everything is made up of little particles. And chemistry really is a study of those little particles and how they all join together. And so this first lesson really is just focused on atoms themselves. So, just from your past knowledge, could you do a quick sketch? Just put the word solid and draw down what the particles are arranged like in a solid, and the same for liquid and the same for gas. Then, what's the name of the process which leads to a gas becoming a liquid? And then in each of those particle types, solids, liquids and gases, how much energy do they have in each of those? So which one has the most energy, which one has the least energy? So could you have a go at doing that, please? And pause now while you do it, and then we'll go on and just go through those bits quickly. Okay, so drawing a diagram for particles in a solid. What should you have done? Well, hopefully you remembered that particles in a solid would be drawn in rows and they would be close together. They're in this structure. So they're close together, they can't be compressed, they're not free to move, although they can vibrate a little bit from side to side. They can't actually move freely. What would you have drawn for a liquid? This is where most people make a mistake. So I'm going to draw a big exclamation mark because that's what people do. Here the particles are still just as close together. They're just not arranged in that regular structure. So you have to draw them close, and if you forgot that, it's worth making a note of. So we've got the particles here in a solid, we've got the particles here in a liquid. The difference here in a liquid is they aren't in that structure, they are close together, but now because it's a liquid the particles can actually move, and they move around in random directions. The hotter the temperature, the faster they move. And then in a gas, what would we have drawn? Hopefully we'll have drawn, most people get this one right, the particles are very far apart, there's big gaps in between them, and they're moving quicker. And again, random directions, so just draw arrows all over the place to show my movement. So here I have close together for a solid, close together but able to move for a liquid, and far apart here for a gas. What's the name of the process which leads to a gas becoming a liquid? Well, for a gas to cool down and become a liquid is called condensation or condensing. And in this bottom one here, the type of describe the energy of each particle. Solids have low energy, just a bit of vibration from side to side. Liquid particles have more energy. So if you look up above here where we were drawing it, here they are moving around with more energy, and here are your gas particles with loads more energy. Okay, so moving on. Chemistry itself, which is obviously our first lesson of chemistry, chemistry is a study of atoms. It's a study of the chemicals, how they're joined together, why these atoms join together, how they join together, how can we make them join together. And it all started with an understanding of actually what an atom is. So here I've drawn some random atoms. So most people, when originally we knew about these, would have, everything's made of small particles and we're going to call those small particles an atom. And the guy who in modern times came up with that idea is called Dalton. That's his second name. And Dalton came up with the idea that based upon his evidence from scientific experiments, he came up with the idea everything's made out of small little particles. I'm going to call those atoms. This orange one I'm just using to show that some particles are different than others. And in chemistry, what actually happens is sometimes the atoms join together. Why that happens, we'll be getting onto. Sometimes atoms go round on their own, and sometimes atoms of different chemicals join together like this. So just to give you an idea, for example, this looks really complicated, but actually once you understand a bit of chemistry, it's quite easy. These black atoms here are carbons. So in this big group of atoms all joined together that we call a molecule, there are 1, 2, 3, 4, 5, there's 6 carbons. So I could write C6. And these little white atoms here, these white ones are called hydrogen. So what I can do is I can say, well, look at counting on there are 12 hydrogens. And here I have 6 of these red ones. These red ones are to symbolise oxygen. So what I've got is C6H12O6. So that's a chemical formula here for this whole molecule. And why is that of any relevance? Well, you eat this every day. You've got it going around in your blood right now. This is actually the chemical formula for glucose. Glucose has a formula, C6H12O6. It's made out of 6 and 12 is 18 and 6 is 24. It's made out of 24 atoms joined in a certain way. A different one, H2O, it's made out of 3 atoms, 2 hydrogens and an oxygen. So chemistry is an understanding of how these atoms work. But actually, what I want to focus on at the moment is atoms themselves. And what occurred fairly early on in discovering atoms was that sometimes these small particles attracted each other. And what we knew about electrostatics was that if you have a positive charge and a negative charge, they attract each other. If you have 2 positives, like this example here, they repel from each other. And if you have 2 negatives, they repel. So could you pause here for a minute and maybe draw these little diagrams here? So opposite charges attract, and like charges, 2 of the same, repel. So opposites attract, likes repel. Okay, when you've done that, move on. And then we've got the fact that all particles have a charge. And this is where we come to really what happened next. So Dalton, as I've said, came up with the idea that, here we are, everything's made out of little particles, and those little particles are atoms. That was in 1808. So what we're talking about there is what? 213 years ago. And about 90 years later, another chemist called Thomson came up with the idea that there was positive charges and negative charges inside an atom. There's a positive, there's a negative, and that these made up the atom. And actually what he was saying with this plum pudding idea, because plum puddings were popular at the time, was here's a big area and it's made out of positive charge and there's little negatives in there mixed in with it. So you might call it a currant bun. There's a bun, all the dough would be the positive charge and all the negatives would be the raisins. That model existed for quite a while, about 25-30 years, until Rutherford. And what Rutherford showed was actually that's not true. If we look at the size of an atom, Rutherford showed that all of the mass of the atom, all of its is right in the centre, and actually the rest of it is nearly all, I'm going to draw that back in my centre, don't know why it disappeared. All the mass is in the centre, and the rest of it, actually, he showed that an atom is mostly made of space. Now, after him came a scientist called Bohr, and what Bohr added onto it was, whilst we have this centre of an atom with all the material in it, around it are areas where the negative charges, the electrons, go around in certain shells and they orbit around the centre. After this, there was one other scientist really that you need to know about, and his name was Chadwick. And what Chadwick did was he worked out, and it had been a puzzle for a while, actually there was too much weight inside here. Inside, change colour pen, sorry. Inside here, inside the new, change colour pen again. Inside here, inside the nucleus of an atom, there was too much weight for the number of positive charges. And what Chadwick worked out was, there's another type of particle in there, and those particles are called neutrons. And neutrons are neutral. Neutrons have no charge. So, within an atom, we have positively charged particles, we have the negatively charged particles going around the outside, the electrons, and then we have neutrons that have no charge. So, can you pause now, and could you do some basic diagrams? And what we're talking about here is 90 years, 30 years, 10 years. And all of this was known. Chadwick's work was back in the 1940s. So in the last 80 years, whilst we've got a greater understanding of it, we're still sticking with the nuclear model of the atom. And the nuclear model of the atom, the modern one, is about the fact that there's a nucleus of an atom which contains all of the mass and the weight, and then around it you've got these shells of electrons. But actually most of an atom is made of space. So like I say, pause, what do you need to get from this? Okay, so moving on, this is more or less the same thing. Dalton, Thomson, Rutherford, Bohr and Chadwick. So have a look at what they've written here on the table. Would this be useful in your notes? I'd suggest yes. If you've already just done it, maybe you can add it to those diagrams. Then second to that, Dalton's name begins with a D. Thomson's name begins with a T. Rutherford's name begins with an R. Bohr's name begins with a B, and Chadwick's name begins with a C. So, if we go with D, don't, and then Thomson, try, and then R, Rutherford, remembering, Bohr for boring, and Chadwick, C, for chemists. Don't, try, remembering, boring, chemists. Actually gives you the first letters. So when you're trying to remember this, and when you're trying to remember who came up with the idea of an atom, it was Dalton, and Thomson was the plum pudding, and Rutherford was the nucleus, and Bohr was the electrons in the shells, and then Chadwick finished it off with the neutrons in the centre. It'll make it much easier to remember if you've got this mnemonic. If you want the exact dates, you can add those now back to your previous models. And the idea is that our model of the atom, and science often works like this, we use models to describe things that we can't see, and actually referring to them as little balls of particles or atoms, and then actually finding out that atoms are actually made of positive and negative charges, and then actually finding out, oh, all the positives are in the centre and all the negatives around the outside. All that happens is, as we get more and more evidence over time, our models get better and better, and this is how all areas of science work. So, fill in the gaps. All particles have charge. So could you write out this green passage in a minute, and could you, after you've written that out, make sure you fill in all the bits here from what we've just done. Then, moving on to this orange section, could you draw the 4 diagrams here, 1, 2, 3 and 4, and next to it write as many of these terms as you can. So for example, this first one, nuclear model, which I'm going to write that next to this one, and I'm going to write it next to this one, because this is when the nuclear model of the idea of a nucleus in the centre of atom came up. Hard sphere. When was the idea that atoms were a hard? I'm going to write hard sphere here. So you can move through that, draw the 4 diagrams. So you've got the green thing to do and then the orange thing to do. Okay. Pause now. Do those, please. Right. Let's see what you wrote. Hopefully, here you wrote charge. This is a property that can be positive, negative, or neutral. Positive charges attract negative ones and repel positive ones. Neutral charges are not attracted or repelled. The discovery of charge allowed scientists to develop their model of the atom. And a model is a theory that scientists use to describe things which cannot be observed directly. And moving on to the next one, what would I have written? I would have put a nuclear model with these 2. Negative charges studied in, I would have put with this. Negatively charged fixed, I would have put here. I just need to move where the camera is. This one is a hard sphere. This one has a positive nucleus, positive nucleus. This is the electron shell model. These would be the protons and neutrons in the nucleus. And all of this here would be empty space. A few final questions, and then what I'd like you to do is take a picture of your work and either send that by Gmail to my Gmail address, or you can submit it by attaching a photo of your work and just pressing the submit button alongside this lesson. Okay, thank you all very much, and I'll leave it there for now.